Hello everyone, welcome to this video. I come up with yet another concept which is called trait chaining or method chaining. The concept is very fascinating concept with respect to Rust in Rust programming language. Basically, this concept is okay. My name is Jiten Palaparthi. If you have ever heard of me, my name is Jiten Palaparthi. You can have a look at my LinkedIn profile. I'm a consultant as well as a corporate trainer. I deliver trainings in Golang, Rust, microservice architecture, Docker, Kubernetes, Kafka, and also cloud concepts uh, as well. I have delivered many trainings, more than I think here it is written as 200 plus. I have delivered more than 400 trainings in these areas. So today's concept is trait trait chaining. Fluent API. Some people call it as a Fluent API. It is a design pattern. It's a pattern basically. What trait chaining is? Trait or interfaces. Traits are analogous to interfaces in other programming language. Particularly traits, we call them in Rust. Trait chaining it's a technique basically. We use this in many programming languages. I will also show you some examples, whether it is a object-oriented programming or non-fully object-oriented programming, kind of a hybrid programming like Go or Rust, where methods of a trait or an interface return the same trait or an interface type. So what happened? If the trait has got multiple methods, you can call them as a chain. These methods can be called as a chain together in a fluent and readable manner. That is what actually the trait or interface chaining. This particular thing we also call it as a fluent APIs, where you can chain method calls in a single statement. You don't need to go and keep on creating a new object or assign the object and call the method. You can call them as a single statement. You can see this object dot add of 100, 200, subtract of 100, multiply of 10, and add of 20 dot get. The ultimate get is going to give you the result after performing all these operations in these methods. Okay, you can have a look at it. That's what exactly the Fluent APIs are method chaining. So if you want to know that what exactly it is, you might have already used this particular concept in other programming languages. If you are from C Sharp, you might have used link queries in .NET framework. Link query snippet is there. You are going to create a query and then you are going to call where, order by, then by to the list ultimately. You're not going to create an object every now and then, but with the same object you call this chain of methods. These are all chain of methods. If you create a builder pattern in either C Sharp or Java, generally builder pattern is you are going to create a build an object with the different properties. So dot set color, dot engine, dot fields, and ultimately this is going to build the object. Ultimately, the concept is chain of methods or Fluent API. How we are going to achieve chain of methods? Of course, there is some difference between how link queries work and the builder pattern works. Uh, Particularly, we are going to use traits for this. So, what is a Fluent API? Fluent interface. Similarly, Fluent interface is it provides an easy to read natural flow by chaining method calls that we have seen earlier. Where it's going to apply where class, it's going to apply order class, order by, and then by to the list. Ultimately, the query is going to give you the list. That is what method chaining or Fluent API almost equal. So generally, Fluent interface we call it in the with respect to builder pattern. Commonly use Fluent interfaces to configure and create objects. Ultimately, builder pattern is going to create objects. Method chaining or also same actually. It's a technique of invoking multiple methods sequentially in a single statement. All these methods that we pass, they will be executed sequentially. Okay, they are not executed in concurrently or parallelly. They are all executed sequentially in a single statement. Okay, how it is possible? Basically, this is possible if all the methods they return the same type. That is nothing but the current object. They have to return the current object because everything has to be applied on the same instance. So all the methods return current object. or all the methods can return an object that implements object of an interface or a trait. This is what actually we are going to do. So let's go to the example. I'm over here. So what I do is cargo new chain uh, chain of methods. Okay, I got to open this chain of methods. I'm sorry, Rust tutorials, chain of methods. I have opened over here. So what I do is I create I would like to same thing. I would like to achieve the same thing, something like this. I would like to achieve something like this. So how you can achieve is create an interface. Let's say I create a trait. I'm sorry, trait. I create a trait which is called iCalc. iCalc is a trait which is called a calculator. Okay, generally this IE notation is not that frequently used in Rust, but I just would like to uh, say that it's kind of an interface, but it's up to you. So what I do is here I create a method called add. It's gonna give a self object. That means the object that it's going to return. It's going to you are calling on a self object, and also I pass a number which is called let it be simple a simple F64. Okay, and generally what we do, we return F64. This is what we do, but here I'm not going to return F64 because the number is added to the number, and then uh, it's going to return the number. But instead of returning a number, I create it as dyn I calc. This is how it is achieved. You see that? Okay, and I also create a method called get. Get is again self. Get is going to return f64. This is the final result I would like to get. You can also implement it if you want, even in the traits. Right, a simple thing. I'm taking away object. I'm applying this. I mean, calling this add method on an object, and then it's going to perform some operation called add, and then it's gonna return the same object. Same object. How do you say same object? Because we are going to apply a trait object. We are going to return a trait object. The trait object is the same trait we are going to use. Cool. Then what I do is I create a type, a unit struct I would like to create now. Let it be a number, very simple number. F64 is a struct, unit struct. Then I call IMPL of iCal for number. You know that this is how you can implement. So fn add and fn get. However, get is nothing but self dot zero because this is what it's going to return. But for add, what it's going to do is uh, return, sorry, self dot zero equal to self dot zero plus number. Because self dot zero is the value here, I'm going to add self dot zero to the number, to the number, to this number. So what it gonna return is return self. You know that return self. I'm going to return a self, but the problem here is this is not mutable. You see that this is not mutable, so you cannot mutate this particular self. What you can do, you can put it as a mutable. So since it is a math object from a trait, here also you have to put it as a mutable. So you are going to create a mutable self. You are performing some addition operation over here and then returning this particular self. For I will also add subtract to the trait. I will add mutable self comma num of f64. Again, this is also going to return divine of iCalc. So here I got to return, I got to implement a subtract. So the same implementation, but only the minus will be there. So I have add and I have subtract. If you want, you can also implement multiply. First, let's examine this. Cool. So what I do here is I'm going to create a new object. So let num1 equal to number of maybe 100, number of 100, but it has to be mutable. Remember that. Okay. I don't know why. I'm sorry, I gave it as F64. It should not be F64. Let it be I64. Let it be simple. I64, and then let it be integer. It got to be I64, I64, 64. This is an integer. Let it be very simple. Integer 64. So this is number. Now what I would like to do is num1 dot add of maybe 100 dot add of 200 dot sub of 300 dot get. Let let result equal to let result equal to. So there is some error. The reason is, if you carefully look at an error, so you are using the borrowing of that particular data, but when you are returning it, it has to be a mutable borrow. If you really look at the implementations of borrow checker with a mutable borrow and immutable borrow, this is not a immutable borrow. This is a immutable borrow. This is not a mutable borrow. Let's what I do is we'll change the this in such a way that it's going to be a mutable borrow. So then, because we are applying that sum on the return type, okay, we are going to apply the sum on the return type. So result equal, you can add as many as you want. You can add as many as you want. Maybe 200, 100 dot subtract of maybe 600 dot get. You can add as many as you want. Chain of actions, you see that. What exactly is going, so 100 plus 200, 100 is already there. Another 100, 200, 200 plus 200 is 400, so 400, 400 minus 300 is 100, 100 plus 100 is 200, 200 minus 600 is minus 400. That's what the result is supposed to be. So print line macro, when I use uh, result, if you want to have a result cd chain of methods cargo run, you're supposed to get minus 400, so you got minus 400. If you want to implement even the multiplication, okay, you can implement multiply. So you pass a number and then here you go to multiply. So what you do, self dot 0 equal to self dot 0 into number, and then return self. So the interesting part here is you are returning the same object, same object of that particular mutable reference of a trait. It's a dynamic trait, dynamic mutable object, same trait object you are returning. Let me call it as a multiply dot multiply of I give as 10 cargo run minus 400. I would like to give it as minus 10. I got it as plus 400, 4000, sorry, not 400. This is how you can implement simple chain of actions. Okay, Fluent API kind of a thing, or a chain of actions using traits. So the most beautiful thing here is the return type must be the trait. If the return type is a trait, what happened. Uh, it's very composable interface. It's pretty neat, and then it solves our purpose. Okay, not only that number, if you implement something else, let's say I would like to implement struct float number, then of course this you cannot apply because we are strictly put it as I64, but you can also implement for float, or you can change this as a what do you say, a generic parameter and then implement it. I don't want to take the video for a long time here, increase the time of the video, but you can do that. If you want, you can do that. Here any number should be passed, or here any number can be returned. So got use a generic to pass the variable, and then since it is you want to apply addition operators or multiple operators or arithmetic operators on generic, then there is another traits that you have to use. However, this is a pretty simple implementation. Okay, I'll put the code and the presentation in the description. Thank you very much for video. Thank you. You have learned something new. Thank you.